Good morning, ladies and gentlemen. This is Mr. Rowe. We're looking in Geometry Part A. This is lesson 11, and we're talking about altitude and orthocenter. And again, we're looking in triangles, the special segments of triangles. So what are some of the properties of the altitude and the orthocenter? Well, the altitude is a perpendicular segment that goes from one vertex to the opposite side. It's perpendicular to the opposite side. I need to add that word perpendicular in there, but I'm telling you, well, it says perpendicular right there. So it's a perpendicular segment to the opposite side. It's also called the height, and we're looking at area and volume and surface area later on. So altitudes can be within the triangle, they can be sides of the triangle, or they could be segments outside the triangle. So an altitude can be a line that's kind of drawn outside the triangle to give you the height of the triangle. If we have all three of the altitudes, we draw all three altitudes. They are concurrent. Again, concurrent means that they intersect at a single point, and that center point, that single point is the orthocenter. And the orthocenter may be inside the triangle. It may be a vertex of the triangle, or it could be outside the triangle. Here are some pictures here. So let's talk about altitude. So you see that the altitude right here is a perpendicular segment. It touches a vertex and is perpendicular to the opposite side. So it could also be in a right triangle. It could be, the altitudes are sides of the triangle. Both of these are altitudes. And then if you have a obtuse triangle, you see right here, this is the altitude right here. It's perpendicular to the line containing this side. That's how it's described in the lesson, the line containing the opposite side. So this line's extended. The right angle formed is right here. So that is the altitude. And again, the orthocenter, this is where you have all three of your altitudes drawn, and the orthocenter will be where they intersect. So if we go back through these, if you have an acute triangle like this one, that orthocenter will be somewhere inside the triangle. If you have a right triangle, then that orthocenter will be this vertex right here of the right triangle. And then if you have an obtuse triangle, well, the obtuse triangle, that intersection will probably be, well, it will be outside the triangle. It could be on either side depending on how it's drawn. This particular problem, let's see, it's going to be down here somewhere. So that's where the altitude, or where the orthocenter is going to be. So what are we going to do with the orthocenter in this lesson? Well, we're going to focus on the coordinate plane and how to find the coordinates of the orthocenter. So if we have triangle ABC and it has vertices at 2, 2, 9, 2, and 5, 8. So 2, 2 is A, 9, 2 is B, and 5, 8 is C. So there's our triangle. We want to find the orthocenter. So what are we going to do? Well, the orthocenter is where the altitudes intersect. So we're going to find two altitudes where they intersect will be the orthocenter. We could use all three, but just to save some work, we know that all the altitudes intersect at a single point, so we're just going to focus on two. So we're going to focus on this line, and we're going to draw an altitude perpendicular to this line. So since it's through this line, it would have to be through that point. So a perpendicular line through that point. And then we're going to use this segment right here, this side, and we're going to find the altitude that goes through that one. So we're going to start with AB. So we're going to find the line perpendicular through point 5, 8. Now what we know is that AB is a horizontal line, so it has a zero slope. Its slope is 0. Lines perpendicular to horizontal lines are vertical lines. So we're going to draw a vertical line right through that point. So since the equation of the vertical line is the x-coordinate, so we look at the x-coordinate of that point, the x-coordinate is 5, and our equation will be x equals 5. If you see we add that vertical line, that's the vertical line. Right here would be the right angle. So we need to find one more altitude so that we can find the orthocenter. We're going to look at the line perpendicular to AB. Well, we've already got that one. AB through 5 8 is x equals 5. Now we're going to look at the equation perpendicular to BC. So we're going to look at this line, and it goes through 2, 2. So it has to pass through this point because it has to pass through a vertex through that point. So let's see how that works out. So to find the equation perpendicular to BC that passes through 2, 2, we're going to start off by finding the slope of BC. Remember the slope formula, y2 minus y1 over x2 minus x1. So we're just substituting these points in. So 8 minus 2 are the y's, 5 minus 9 are the x's. That equals 6 over 4, which turns into negative 3/2. Now, perpendicular lines, we talked about this in a previous lesson. The line perpendicular to a line has to be a reciprocal and an opposite. Remember, the product of the slopes must be negative 1. So the perpendicular slope, if we flip 3 over 2, we get 2/3. Since this one's negative, then this must be positive. So that's how we get 2/3. So now we're going to use 2/3 and the point 2, 2 to write the equation. So we're going to use slope or point slope form, substitute. We're going to distribute 2/3 times x is 2/3 x. 2/3 times 2 is negative 4/3. Now we're going to have to add 2 to each side. That's the same thing as adding 6, because 6 divided by 3 is 2. And so that's going to end up giving us an equation of y equals 2/3 x plus 2/3. Now, so that line will go right through that point, just like that. So you notice the slope is 2/3. So if we count 1, 2, 1, 2, 3, we're at a point. 1, 2, 1, 2, 3. So that's why we have that equation. Now, if we look at these graphs, these two lines, these blue lines, it looks like they intersect right there. Now, we can't be always sure with a graph, but just by, visually looking, we can probably see that the orthocenter is going to be 5, 4. So we're going to verify that the orthocenter is at 5, 4. We already know that x equals 5 because that was the equation for the first line. So we're going to substitute x equals 5 into this equation. And so what's 5 times 2/3? Well, that's 10/3. What happens when I add 10/3 and 2/3? I get 12/3. So that means y equals 4. So yes, we just verified that the orthocenter right there is at 5, 4. So I hope this helps you with the problems involving orthocenter in the lesson. If you're still struggling with the content, please let me know in a teacher message or make an appointment for a help session.